Okay, so today we're going to be doing part 3, where we're looking at our unit circle, and we already spoke about how you can model, different angles on a circle with radius 1. And for example, we talked about if this is 30 degrees, we said because the hypotenuse is 1, the legs are the square root of 3 over 2, and the hypotenuse is a half, or the other leg is a half. And so, we were talking about, since the hypotenuse is 1, this is the y coordinate, this is the x coordinate. And so if that's theta, we can talk about the sine of theta being the y coordinate, or the y coordinate over 1, the cosine of theta being the x coordinate, or the x coordinate of 1, and tangent of theta being y over x. We also said basically these coordinates are x then y. We can say every ordered pair that you see here, like this is the square root of 3 over 2. This right here is going to be a half, comma, parentheses, our cosine for the x coordinate, and the y coordinate is the sine of theta. And so we can reduce and rationalize any of our answers as we need to, and we can use our unit circle to help us. And you may have noticed on your homework last night that some of the values of sine, cosine, and tangent can be negative, and that's especially if they're obtuse angles, okay, bigger than 90 degrees. You'll notice if you evaluate, say, the sine or cosine in the second quadrant, and so this right here is going to be 150 degrees here. And because this is going to be left the square root of 3 over 2 and up a half, because those are going to be these legs here, then you can say, well, we can focus on the cosine would be negative square root of 3 over 2, the sine would be a half. And if you checked it in your calculator, they would give you the decimal approximations of those answers. So it's kind of cool to see we can evaluate those in different quadrants using our unit circle, okay? But what we have to recognize is that those obtuse angles, those angles that are bigger than 90 degrees, are actually reference angles. They're actually our special 30, 45, and 60 degree angles just placed in other quadrants. What do you mean, woman? Well, the deal is that if you go to 150 degrees, yes, the angle that you travel is 150 degrees, but the distance from the x-axis, the right triangle or the reference angle, it's a 30-degree angle in the second quadrant. And so if I say, okay, well, what is the reference angle, or what is the angle, for this one right here, 120 degrees, well, you're like, well, that reference angle is actually 60 degrees because it's 60 degrees from the x-axis. And so the one between them would be a 45-degree angle just placed in the second quadrant. And so if you go to those obtuse angles, the reference angle is, when you get there, how far is it from the x-axis? And so, okay, well, tell me this. How many degrees would be a 30-degree angle in the third quadrant? Remember, this is quadrant 1 and 2, and then this is 3, and this is 4. I should be using Roman numerals, so let's do that. 1, and this would be 2 i's, right? And then 3. And then remember, 4 is IV. Okay, let's take 1 from 5. So V is 5. So 1 take away from 5 is 4. And so if you put a 30-degree angle in the third quadrant, well, the third quadrant is down here on the bottom left. Well, if you go 30 degrees away from the x-axis, okay, again, your reference is going to be the x-axis. Okay, how far is it from the x-axis? So if you go 30 degrees, reference angle from there, that would be 180 plus 30, and so that would be 210 degrees. So the reference, an angle that's a 30-degree reference angle that's in this third quadrant would be actually 210 degrees. Okay, and so if you're like, okay, well then what would you do if you had like a 60-degree angle in the third quadrant? What would be its, what would it be? Well, that would be when the measure is 60 degrees away from the x-axis. And so that would be 240 degrees. Okay, so, and they could ask you, okay, go to 240, what's its reference angle? When they ask what its reference angle is, would be how far is that obtuse angle, like massive angle, how far is it from the x-axis? Okay, and so what would be a 30-degree angle that you'd place in, say, the fourth quadrant? Well, if you place a 30-degree angle in the fourth quadrant, well, that would be here. And so that would be, that's 360 is all the way around, so it'd be 330 degrees. And so I could say, hey, what's the reference angle of a 33-degree angle? You say 30 degrees. Because when you graph this, when you go all the way over here, how far is it from the x-axis? It's 30 degrees. Okay, and so placing those very big angles and saying, well, then once you graph them, how far are they from the x-axis would be the question we're trying to answer. Okay, so that's kind of an interesting way of speaking. And so in class today, 7th hour, people were talking about, let's practice this. And I was like, okay, cool. And they're like, all right, well, what is the reference angle for, let's see, I'm trying to think what they said. Can't remember exactly, so I'll just kind of make up something similar. They said, what would be the reference angle if you went, if you had a 50-degree angle in the second quadrant? Okay, so the reference angle is 50, and if you put it in the second quadrant, what angle would that be? So if you went to 50 degrees from the x-axis, well, what angle would you have to graph to have a reference angle of 50 degrees? Well, that would be 130 degrees, okay? Because remember, 180 is when you're right here, and it would be 130 that you'd have to graph to have a reference angle of 50 in the second quadrant. So let's see what else we talked about today. We also spoke about answering these questions. So I'm going to have you make a list of problems that we can do, okay? So I say, okay, let's practice doing the sine of 150 degrees. Okay, so you go to 150 and look at your unit circle. You'll notice that's right here. And remember, it's cosine and sine. So what is the sine of 150? Sine is going to be the y-coordinate, and so that's going to be 1/2. Okay. Okay, so then I was like, okay, what is the cosine of 150 degrees? Okay, let's see about that. If you do the cosine of 150 degrees, that would be the x-coordinate 150. Okay, that's negative square root of 3 over 2. And so because in the second quadrant, your x-coordinate is negative square root of 3 over 2, your y-coordinate is 1/2. Yeah, in the second quadrant, you will notice that your cosines are going to be negative, okay? What if I ask you what the tangent of 150 degrees is? Remember, you put the y-coordinate over the x? Well, let's see if I've got room for this. I'll scooch it up. If you put the y-coordinate over the x, you go, the y-coordinate is 1/2. The x-coordinate is the square root of 3 over 2 negative. How do you deal with that? Well, a couple days ago, we talked about how do you deal with it when there's a complex fraction, where there's fractions on fractions. Well, what you do is you times the top and bottom by that common denominator, and it cancels it out. And you get 1 over negative square root of 3 over square root of 3. You have to rationalize it, so rationalize it. You get negative square root of 3 over 3. So that would be what the tangent of 150 degrees. And if you punch that in your calc, it would give you the decimal approximation of it. So you got to remember, tangent means the y-coordinate over the x, and you reduce it. So we just did a couple more. It's like, okay, what is the tangent of 315 degrees? Okay, you're like, okay, where's that? Oh, I remember, it's down here, 315. That's has a reference angle of 45 degrees. If you look at these points, you go the square root of 2 over 2 is x, negative square root of 2 over 2 is the y. Okay, let's do it, y over x. So negative square root of 2 over 2 over square root of 2 over 2. What does that reduce to? It's -1. Okay, and so that's kind of cute. It's -1. Okay, let's do another one. What is, I should have erased some of these things just so we got some more space. What is going to be, that's not wanting to erase for me. What is the sine of 90 degrees? Okay, let's write that down. Sine of 90 degrees. Okay, the sine of 90 degrees is going to be the y-coordinate. Okay, and so it's going to be 1. And then if I say, what's the cosine of 90 degrees? Okay, that's 0. What is the tangent of 90 degrees? Okay, that's going to be the y over the x. That's 1 over 0. Wait, that's undefined. And if you remember, when you draw a tangent, Okay, and so, okay, what about 180 degrees? Okay, what's the sign there? Well, the sign at 180 degrees is going to equal the y coordinate, and so that's going to be 0. And then cosine is going to be -1, and tangent will be 0 because it's the opposite of it is going to be the y over the x, so it'd be 0 over 1, which is 0. So being able to look at these and say, can I use these coordinates and say, yeah, the x coordinate is the adjacent leg, so that's going to be cosine. The y coordinate is going to be the sine, so that's going to be the opposite. And then tangent would be the y over the x, because that's going to be the slope. So if you think about it, if you go left or right, the slope at 0 or 180 is always going to be 0, but the slope as you go uphill in the first quadrant is going to be positive. If you go downhill, it's going to be negative, so tangent is sometimes negative. And yet, if you find the tangent of a 90 degree or 180, or not 180, 270, yeah, both of those are going to be undefined because the slope at 0 or at 90 or at 270 is going to be undefined. So we're kind of orchestrating, bringing together quite a few concepts to say, hey, can I do the ordered pairs? You know, can I say x or y over x? Can I remember that slope means y over x? Because it's the rise over the run. If you look at that triangle that's off to the side. And then also, now we're going to be talking about something called radians. Okay, and so reference angles are the distance from the x-axis. Oh, actually, I lied. The next thing I'm going to talk about would be, what if I asked you to graph or figure out where is -45 degrees? Okay, do you know where that would be? And so -45 degrees would be, well, you know, if I said go forward 3 steps or backwards, again, positive 45 degrees would be to be right here, okay? Because you're going in a positive direction 45 degrees. If I say go -45 degrees, that means go backwards in an opposite direction, backwards through the quadrant. So 4, 3, 2, 1, go backwards 45 degrees. Okay. And so I could ask you, okay, can you tell me what the sign of -45 degrees would be? And so you would say, okay, -45 degrees would really be equivalent to asking what the sign of positive 315 degrees would be. Okay, so they're synonyms. Okay, so you could get to the same location by going backwards 45 degrees or going forwards through the quadrants, positive 315. And you say, okay, the sign would be negative square root of 2 over 2. Okay, and so if I said, okay, go negative, let's see, go, let me think about that, sorry. Let's find the cosine of negative 210 degrees. Okay, where would that be? Well, positive 210. I've got a lot of stuff on here, and it's really hard for me to erase. If you go positive 210, you would notice that, I can't erase some of it. If you go positive 210 degrees, you would get to here. Well, what if you went negative that same dimension? Okay, going negative 210 degrees would be going backwards through the quadrants that same amount. You would end up actually being at 150 degrees. Okay, so finding the cosine of 150 degrees would be the same thing. And so you'd get negative square root of 3 over 2. Okay, so that's kind of an important thing to work on. I am going to, because I can't erase so much, I'm going to pause the video, get a new screen, and move to the next page of these notes so that you guys can see what I'm doing a little bit easier. Okay, so we need to talk about something called radians, okay? And so just like we talked about, we can talk about the measure of an arc, okay, which would be the number of degrees you went. So if you run 90 degrees on the track, well, how many yards or meters might you run? I don't know. You have to do some math there. But you can also talk about arc length, where that is going to be the length that you ran. So you're like, oh, I run 400 meters or 400 yards or whatever you did. Same with on a circle. We can talk about, hey, I went 20 degrees, I went 30 degrees, I went 60 degrees, etc. Or you can talk about the arc length. And so we are going to talk in terms of degrees around a circle, where we've got the 30 and we got the 45, etc., and the 60 degrees from. Okay, so if we're going to talk about the circumference of this unit circle, okay, so what is the circumference? Circumference is equal to 2 pi r or pi d. Well, this is a unit circle. What's the circumference of this unit circle? Well, the circumference is equal to pi times 2 times pi times r. Well, since r is 1, because it's a unit circle, the radius is 1, the circumference equals 2 pi. So if you're at 0 degrees, you've gone 0 radians, okay, 0 pi radians, or distant, the length around a circle. But if you've gone 360 degrees, you've gone 2 pi. All the way around the circle would be 2 pi, because that's the circumference of one circle. Well, what if you go 180 degrees? How far lengthwise have you gone around a circle? Well, we've gone pi around a circle. Okay, and so 180 degrees is equal to pi, okay, because all the way around a circle is 2 pi. Well, pi would be halfway around a circle. Okay, so what we're going to do is we're going to figure out what are the radian measures, okay? It technically is the distance around the circle you've done. In terms of how many radiuses you've traveled, that's kind of a weird concept. Around one circle is 6.28, or 2 times pi, which is 2 times 3.14, 6.28. So a little bit more than 6 radiuses. That's one way to think about it. Another way is basically if the radius is 1, all the way around a circle is 2 pi, halfway around a circle is pi. And so we're going to talk about what fraction of the circumference did you do to get around the circle. Okay, so 2 pi is all the way around, pi is halfway around. And so then that means to 90 degrees would be pi over 2, okay, halfway to pi. If you go 3/4 of the way around the circle, that would be pi plus another 90 degrees. So it'd be 1.5 pi if all the way around is 2 pi. And so that would be 3 pi over 2, 1.5 pi. If you divide 3 by 2, you get 1.5 pi. And so again, we're talking about how, if all the way around the circle is 2 pi, what fraction of that have you gone, as an equivalent way to talk about degrees. And the reason why we use something called radians is because a lot of formulas when you grow up only work not in degrees, but in radian measure, okay, which is proportionally how many radiuses you've walked around the circle, or just a fraction of the total circumference of the circle. So there's kind of a lot of layers to talk about. We'll just kind of focus a little bit, okay, on some of the stuff, that kind of basic understanding. So if we do 45 degrees, we can say, okay, well, that means that if halfway around a circle is going to be pi, quarter of the way around the circle for 90 degrees is really pi over 2. This would be 1/4 of the way around a circle, or pi over 4. And so this is 1/4 of the way around a circle. This would be add another 45 degrees would be 2/4, okay? 2/4 of the way around a circle, or pi over 2. If you go to add another 45 degrees to this, you're going to get 3/4 of the way around to pi. If you add another pi over 4, you get 4 pi over 4. Well, 4 pi over 4 is just pi. You go another 45 degrees, you're going to get 5 pi over 4. Notice it's improper, so it's more than pi. If you add another 45 degrees to here, you get 6 pi over 4. Well, 6 pi over 4 reduces to 3 pi over 2, so leave it like that. If you could do another 45 degrees, you get 7 pi over 4. If you go all the way back here, you get 8 pi over 4, which is going to be 2 pi. So we'll leave this as 2 pi. So we've got kind of the 45 degree angles on there. Our next step would be to get the 60s and the 30s on there. And so to get the 60s and the 30s on there, we're going to say this is actually going to be 1/6 of the way to pi. So like if you cut this up, there's going to be 6 measurements, to get to pi. Okay, there's 6 pieces of pi to get there. Also, if pi equals 180 degrees, if you do pi or 180 divided by 6, you actually get 30 degrees. So 30 degrees equals pi over 6. It's 1/6 of the way to pi. And so if you added another 30 degrees to it to get to 60 degrees, you would have 2 pi over 6, which is pi over 3. So we're going to call it pi over 3. If you go another 30 degrees, you would get 3 pi over 6. Okay, we're adding to 2 pi over 6. We get 3 pi over 6. Well, it's just pi over 2, so leave it like that. If you go another 30 degrees, you get 4 pi over 6. So 4 pi over 6 reduces to 2 pi over 3. 2/3 of the way to pi, that's true. The next one would be at another 30 degrees, and you're going to get to 4 pi over 6. You're going to get 5 pi over 6. And if you go another 30 degrees, you get 6 pi over 6, which is just pi. So we're just kind of saying what fraction of the way are you going around the circle? All the way around the circle is 2 pi. What would be these next steps? Okay, how can we do this? And so let's do, if you add another 30 degrees to 5 pi over 6, you're going to get, or to 6 pi over 6, you're going to get 7 pi over 6. If you go another 30 degrees, you're going to get 8 pi over 6, which is, what is 8 pi over 6? It's going to be 4 pi over 3. And then 9 pi over 6 is down here. And that reduces to 3 pi over 2. If you go another 30 degrees, you're going to get 10 pi over 6. Let's reduce that to 5 pi over 3. If you go another 30 degrees, you're going to get 11 pi over 6. And if you go another 30 degrees, you get all the way home, you get 12 pi over 6. Okay, and 12 pi over 6 is going to be 2 pi, and that's going to be all the way around a circle. So what we're going to do with these radian measures would be, yes, special formulas, but also what we're going to do with them is we're going to say, okay, what is the sign of 4 pi over 3? You're like, well, what is that? Well, 4 pi over 3 is going to be down here. That's just going to be a 60-degree angle in the third quadrant. So you're like, okay, that's like the same as asking you that question exactly right here. Okay, so if you're saying a 60-degree angle in the third quadrant, and so if I say, what's the sign of that? You're going to say negative square root of 3 over 2. Okay, and so, and I could say, what is the sign of negative pi over 6? Like, I don't know. We'll go pi over 6 is 30 degrees. We'll go backwards that direction. You would end up right here and say, what is that sign? You're going to say negative 1/2. And so being able to say, what are those measurements? What do they mean? What fraction of the circle? If all the way around the circle is 2 pi, because 2 pi r means 2 pi, if the radius is 1. And what fraction of the circle have you traveled? Rather than in degrees, we call it radians, okay? Because it's based on the radius of this circle, based on the circumference. So it's just another way of asking this question. All right, well, thank you so much. Have a good day.